Hello everyone. So, this video we will be learning about multiplexers. What is a multiplexer? A multiplexer is also a combinational circuit just like the other circuits, but it has many data inputs but a single output. It does not have multiple outputs. It has multiple inputs but it has only a single output depending on the control signal or the select signal. Okay, so here uh, for a multiplexer the equation is for 2 to the power of n input lines, n selection lines are needed. So here the diagram, as per the diagram that they have given, so this is the example for 2 to the power of n is to 1 multiplexer. So 2 to the power of n inputs, 1 outputs. So input data lines are 2 to the power of n, which means if n is 1, so 2 to the power of 1, which is 2. So 2 inputs will be there. If n is 2, that is the number of select lines are 2, then 2 to the power of 2, 4 inputs will be there. So for 2 to the power of 1, which is 2 is to 1 multiplexer, one output line will be there and one selection line will be there. For 2 to the power of 2, that is 4, 4 is to 1 multiplexer, 4 select lines will be there. 1 2 3 4 input lines will be there. 1 2 3 4, and as n is 2, 2 select lines will be there. 1 2, and one output line will be there. Similarly for 3, 2 to the power of 3, for 8 is to 1 multiplexer, 8 inputs will be there and 3 select lines will be there and one output line will be there. For 2 is to 4, which is 16 is to 1 multiplexer, 16 inputs will be there, 4 select lines will be there and one output line will be there. So there are different multiplexer, 2 is to 1, 4 is to 1, 8 is to 1, 16 is to 1. Okay, so this is the example of 2 is to 1 multiplexer, where is input IO, I1, these are the two inputs. There is one select line which is called as S0 and there is a output. So as there are two inputs, definitely there will be 4 different combinations: 0 0, 0 1, 1x and 1x. So what is this x? I will be telling you about that. So here first we write, how we'll write the truth table? We'll write the main inputs I0 and I1. We'll write that. We'll write select line, as this is 2 is to 1 multiplexer, so one select line will be there. We will name it as S0, and there is one output which we will call as Y. So for I0 and I1, so depending on that, so what are the values for the I0 and I1? So for I0 value 0, for I0 value 1. So what is the value of I1? Depending on that, we can decide what is the output. So for I0 0 1, we are taking select line as 0. So 0 will be common for I0 values, whereas for I1 we will take 0 1, and for I1 we will put select value as 1, but we don't know the I0 value. So the output is dependent on both these cases. So how is this truth table written? So see, when S is 0, when select line is 0, then I0 is selected. So as I said you, when S is 0, in these two cases, I0 is only selected. This is not selected. I1 is not selected. Okay. So the values are 0 and 1. It's just like it follows the input value. So input is 0, output is 0, input is 1, output is 1. If S0 is 1, so this S0 value is 1 in this case, then I1 will be selected. So that's why I1 is selected here, 0 and 1, and I0 is disabled. So this is the form of disabling. X is the form of disabling. So this is the disable form. So output will be following the input. So 0, output will be 0, 1, output will be 1. So S0 is just the selection point. So it is 0 and it is 1. So why 2 zeros? Because it will select I0, and for I0 we have two different values, 0 and 1. For 1 it will select I1, and for I1 also we will have two different values. For 0 it will select I0 and it will disable I1. For 1 it will enable I1 and it will disable I0. So this is the circuit diagram of 2:1 multiplexer. So If I naught is there, okay, if I naught is there, then S0 is, sorry, if S0 is 0, then I naught is selected. If S0 is 1, then I1 is selected. So if here S0 is 0, so for 0, we tend to do the diagram as the output will be that output Y will be equal to S0 times I0 and S0 times I1. So S0, uh, for S0 it will be complement of S0, then I0, and for I1 it will be I1 and S0 will be taken as it is. So S0 is taken as it is here for I1, whereas S0's complement is taken. That is why inverter is put. So inverter and I0. So these two are combined with an AND gate, and the combination of these two is passed through an OR gate. So here we have an OR gate. So Y. So this is the diagram of 2:1 multiplexer. Similarly, we have 4:1 multiplexer where we have 4 different inputs: I0, I1, I2, I3. So as there is 2 to the power of 2, 4 different inputs. So N is 2, so 2 different select lines, S0, S1, and there is one output, Y. Okay. When S1, S0, both are 0, then I0 is selected. When S1, S0, S1 is 0, S1 is 0, S0 is also 0, then I0 is selected. When S1 is 0, but S0 is 1, okay, so this is 1, then I1 is selected. When S1 is 1 and S0 is 0, I2 is selected. When S1 and S0 both are 1 1, so I3 is selected. So this is nothing but this is just the binary decomposition. For 0, I0 is selected. For 1, I1 is selected. 2, this is the equivalent of 2, so I2 is selected. This is the equivalent of 3, so I3 is selected. For 4:1 multiplexer, we have S0, S0 and S1, and then we have Y. So this is the truth table. For 0 0, I0 is selected. 0 1, I1 is selected. 1 0, I2 is selected. 1 1, I3 is selected. So the final equation of 4:1 multiplexer is S0, S1, S0, S1 naught, I naught, which is this, then S0, S1, I1, then S0, sorry, S0, S1 naught, I2, S0, S1, I3 combined with the OR gates. So for this you will draw a logical diagram. So for S0, this is the inverter, then we have S1 naught, this is the inverter, then we have I naught. So these three we will take and combine with an AND gate. Similarly, we will do S0, this is the S0, then we have S1, we will take S1 here and we will take I1 here. We will combine these three, we will put an AND gate. Similarly, for this equation we have this, for this last we have this. So we will combine all these 4 outputs in a single OR gate because we have OR in the middle. So they will pass through an OR gate. So this is the diagram of 4:1 multiplexer. Okay. So there are different ways we can implement gates as well using the 2:1 multiplexer and all. So that I will discuss in the later videos. So in this topic we learnt about 2:1 multiplexer and 4:1 multiplexer.